Okay, welcome back. Now that we've found the area of a few acute triangles, let's try a few obtuse triangles. You'll notice that we do have side, angle, side, so we can go ahead and proceed. The only difference here is that our altitude is going to be on the outside of the triangle instead of the inside of the triangle. So I'm going to go, I went ahead and I dropped my altitude. This is now my height. Here's my little right angle. Here's another angle. And the 10.2 is my hypotenuse. You'll notice that I don't have this angle here, but it's the supplementary angle to the 125 degrees because this is a straight line here. So in order to find that, you know that supplementary angles have to add up to 180 degrees. So I would just subtract 125 degrees from both sides, and I'd end up with my angle is equal to 55 degrees. So I'll go ahead and label that here. So now I can go ahead and use the sine ratio to find the height. The sine of 55 degrees is going to be equal to the height over 10.2 centimeters, which means that my height equals 10.2 centimeters times the sine of 55 degrees. Note that I'm in degrees. That means my calculator, I'm working with degrees, so my calculator should be in degrees. Now I can go ahead and plug in for the area of a triangle. I have everything I need. I have 1/2. My base is 6.4 centimeters. That's at the bottom of my triangle. And my height is 10.2 centimeters times the sine of 55 degrees. I'm putting all that in one step so that I don't have a rounding error, and I get 26.7, well, about 26.7 centimeters squared. Here's one for you to try. Pause your video, try this out. When you're done, restart the video and check your answers. Okay, hopefully you got the right answer. Here's our little angle, here's our height, right there, and here's my hypotenuse. The angle here is supplementary to 105, so that ended up being 75 degrees. So the sine of 75 degrees equals the height over the hypotenuse, which was 21. So our height is 21 sine of 75 degrees. Area is then going to be 1/2 15, because 15 is my base, times the height, 21 sine of 75 degrees. That makes the area 152.1 centimeters squared. So in general, when we're finding the height of a triangle, if it's an acute triangle, it's the sine of the angle, which in this case is angle C, is equal to the height here divided by the hypotenuse on this side of the right angle, across from the right angle. If our triangle is obtuse, well then our height is on the outside of the triangle, and the sine of the angle is actually, if this is angle C, is actually 180 minus C, and that equals the height over our hypotenuse B here. Hey, wait a minute. why don't you just try C and see what happens? You'll notice, if you just pick any random value for C, you'll notice that the sine of C is equal to, the sine of 180 minus C. Why does that happen? If you wanted to earn 2 bonus points in the P competency, figure out why the sine of C is equal to the sine of 180 minus C, and email me a detailed answer about why. If you're right and your answer makes sense, then I'll give you 2 bonus points in an existing P competency. So in general, the height is equal to B sine C, and actually whether our triangle is acute or obtuse, because the sine of 180 minus C equals the sine of C. Don't forget to email me your answer. So in general, the area of a triangle ends up being 1/2 A, because it's my base in this case, and B sine C, because that's the height. Okay, for all you formula Nazis out there, depending on which 2 sides and included angle I have, there's a formula for each scenario. I'm going to encourage you not to memorize the formulas, though. I would rather you understand the process. That way you don't need to spend time trying to remember complicated formulas. The formulas you need are the area of any triangle and the sine ratio. Your steps are going to be to figure out if you can even find the area. In order to do that, you need side angle side. You need to drop an altitude. I'm just going to abbreviate that. And you drop it from the known angle. And last, you use the sine ratio to find the height. And then you just plug it into the formula for an area of a triangle. Done.